January 15, 1935. A locomotive dismissed by executives as an expensive styling experiment just shattered a speed record, outpacing electric locomotives built specifically to dominate that route. What Pennsylvania Railroad's board saw as a beautiful mistake was about to prove something dangerous to traditional engineering thinking. Elegance and raw power were not enemies. January 28, 1935. Between Philadelphia and Harrisburg in freezing winter conditions, engineers watched in disbelief as the new GG1 maintained 100 miles per hour, hauling 640 tons, while conventional electrics were forced to throttle back to avoid overheating. Through snow-covered rails, the GG1 moved with impossible grace. 477,000 pounds of steel, streamlined, quiet, relentless. This wasn't how electric locomotives were supposed to look. No boxy bodies, no exposed machinery, no brute force industrial ugliness. And yet, it delivered more sustained power than heavier, supposedly superior designs. By 1934, the electric locomotive industry followed one rule: function over form, maximum weight, maximum traction, zero concern for beauty. Then Pennsylvania Railroad broke every convention. Instead of letting engineers dictate the appearance, they hired Raymond Loewy, an industrial designer known for coffee makers and refrigerators. To railroad traditionalists, this bordered on heresy. Critics mocked it. Trade journals warned it was marketing over mechanics. Competing railroads scoffed at the streamlined fantasy. And shareholders questioned why these locomotives cost 15% more than proven designs. What they didn't understand was simple: streamlining reduced resistance. Integrated bodies increased strength. Better weight distribution improved traction and ride quality. The GG1 wasn't engineering compromised by beauty. It was engineering evolved. And as it tore through the Keystone Corridor that winter, one truth became impossible to ignore. The future of electric traction didn't belong to heavier machines. It belonged to smarter ones. The collaboration between Raymond Loewy and Pennsylvania Railroad's engineers uncovered something the locomotive industry had missed for 50 years. Chief Mechanical Engineer William Ayers understood electric traction better than almost anyone alive. Loewy brought something railroads had never seriously applied to motive power: aerodynamics, material efficiency, and integrated design. Together, they questioned assumptions no one else dared to touch. That streamlining was useless at railroad speeds. That exposed machinery was essential for maintenance. That boxy bodies were stronger. They tested every belief. Wind tunnel analysis revealed that at 100 miles per hour, streamlining reduced air resistance by 32%. Power no longer wasted pushing air, but pulling trains. The GG1's riveted carbody wasn't decoration, it was structure. A unified shell that distributed stress better than heavy internal frames, allowing less weight and more strength. Even the nose critics mocked improved forward visibility and protected sensitive roof equipment from damaging wind forces. Nothing was cosmetic. Everything worked. Underneath, 12 General Electric traction motors delivered 4,020 horsepower, spread across 24 wheels, giving adhesion conventional electrics couldn't achieve, even with more weight. The electrical system was just as radical. Quill drives isolated motors from track shocks. Active cooling prevented overheating. And a transformer powerful enough to maintain full output from 0 to 100 miles per hour eliminated the power fade other electrics suffered above 70. Industry reaction was immediate and dismissive. Trade journals warned of maintenance nightmares. Competing railroads insisted heavier box cabs meant better freight performance. Engineers predicted failure. Then the GG1 entered service. It ran 100 miles per hour for over an hour without overheating. It returned power to the grid through regenerative braking. It used 31% less electricity than competing electrics. And in June 1936, a single GG1 hauled 1,040 tons, nearly double its rated load, arriving on time, with temperatures still within safe limits. The verdict was unavoidable. Streamlining didn't weaken engineering, it unlocked it. The GG1 proved that maximum performance didn't require maximum weight, only maximum intelligence in design.
Pennsylvania Railroad's greatest engineering triumph outlived the railroad itself. The collapse of America's most prestigious railroad in 1970 wasn't caused by the GG1, it was caused by boardroom decisions, most disastrously, the Penn Central merger. The company that built locomotives designed for 50-year service lives disappeared after just 35 years. The locomotives didn't notice. When Penn Central went bankrupt, GG1s built in 1935 were still hauling premier passenger trains, outperforming newer diesel locomotives already scrapped. Their rivals told the story. New Haven's EP3 electrics were retired after 27 years. Milwaukee Road's massive box cabs were abandoned entirely. The GG1s kept running. In 1971, Amtrak inherited 30 GG1s. Consultants demanded replacement. Inspections said no. After 36 years, GG1 still delivered over 90% of original motor output. Operating costs were $127 an hour. New locomotives would cost $180, with no advantage. Amtrak kept them. By 1983, each GG1 had traveled 4.5 million miles. The lesson was unavoidable. Beauty wasn't decoration. It was discipline.